Gaia finds huge waves sweeping through the Milky Way. We've got a launch date for Artemis II. Lava tubes might have been found on Venus. And in Space Bites Plus, Venus's clouds are mostly made of water. All this and more in this week's Space Bites. Gaia may be gone, but the science continues to roll out. And thanks to Gaia, we learned a lot more about the composition of the Milky Way, where all the stars are, how they're moving. And one really interesting mystery about the Milky Way is that the disk of the galaxy is warped. And we've known about this for decades, since the 1950s. But thanks to Gaia, we have also learned that this warp wobbles like a top as the galaxy is rotating. And now, new information from Gaia shows us that there are waves that are sweeping out through the Milky Way that are sort of like waves moving across an ocean. Or think about like the waves when people are standing up at a stadium and then sitting back down again. So I want to show you a picture that highlights the regions of the Milky Way where this wave is currently sweeping out through the Milky Way. And then another image that's even more useful shows you, not quite to scale, but how much the stars are either moving up or down from the galactic plane. And that just shows you this sort of sideways wave-formed motion. Now, why is this happening to the Milky Way? Well, we don't know. But generally, these kinds of large-scale changes to a galaxy structure comes through the history of its mergers. And so we know that the Milky Way has gobbled up a whole bunch of dwarf galaxies in the past. And so maybe one of these dwarf galaxies, as it was consumed like a rock dropping into a pond of water, it's created ripples through the galaxy. But no specific merger event has been tied to this structure. You know, I think it's really important that even though Gaia is gone, I will continue to bring you stories about what Gaia did. And we're leading up to the next big Gaia data release 4, and then the next big data release after that, data release 5. So you're looking forward to, I don't know, like another decade of me raving about the Gaia mission. How time flies. It has been over 50 years since the first human beings set foot on the moon. It has been over 50 years since the last human beings set foot on the moon. And finally, humans are going back to the moon. This week, NASA announced that the Artemis II mission has a launch date. They're going to try to launch in early February 2026. That's not too far into the future. And a lot of the work has already been done. The Space Launch System, center stage, upper stage, the booster rockets, these have all been built, stacked up, and are ready to go. The astronauts have been chosen for the mission. And that mission is to fly around the moon, not land on the moon, but fly around the moon, similar to the Apollo 8 mission. The mission is expected to launch in February. We'll spend 10 days in space with several of them in the lunar environment and then bring the astronauts safely back to Earth. And when that mission is complete, this will be the farthest and longest that humans have been away from the Earth in human spaceflight. And we also got the announcement that the crew have named their capsule Integrity. So that's all good news, and hopefully we will see the Space Launch System take off again. It's a gigantic rocket, shook apart pieces of its launch gantry last time, and it would be great to see humans actually go on this mission out to the moon and back. But of course, then we have to start thinking about what happens after that, and that is, of course, Artemis III, and this is where a crew of astronauts will set foot on the moon. That's expected to launch in the middle of 2027, so about 18 months after Artemis II takes off. But what are the chances that it is actually going to fly on time? There was a recent meeting of the members of the Aerospace Safety Advisory Panel in September, and they doubted that the SLS will be ready in time. And the problem, of course, is that we're waiting not only on the Space Launch System, which is, that's all being put together, but we're waiting on the Human Landing System, which is going to be this modified starship that is going to refuel in orbit, fly to the moon, and serve as the lander for the astronauts. Although Starship has been making progress, we're still a ways away from that reusability that it's going to take to be able to launch multiple starships into orbit and to refuel them, and then for one of those to go to the moon, and then to demonstrate that it can land on the moon and then go back up into orbit. And then there are other parts that could be a cause for delay. We don't know if the spacesuits are going to be ready in time. So there's a lot of moving parts to get humans back to the surface of the moon. And I think a lot of people are starting to express concern that the Chinese are going to be setting foot on the moon probably by 2030, and that could very well beat the Americans back to the moon. So we'll keep you posted on all of this, but still, it's exciting to see Artemis II is getting closer. I've got a story about this from Matt Williams on Universe Today if you want to read more. Another topic that I'm really excited about are rogue planets. These are planets with the mass of the Earth, maybe the mass of Jupiter, and they are freely floating through the Milky Way without a star. And it's only in the last couple of years that we have actually identified these rogue planets. And they're really exciting because, in the past we thought, well, all of the planets in the Milky Way are found around stars. And that now we're learning actually there could be as many rogue planets just free floating between star systems, or maybe even more than there are planets around stars. These could be much closer to the solar system than the nearest star. James Webb is the perfect telescope for examining rogue planets, and one interesting one is called SIMP 0138. It's located about 20 light years away, and astronomers have known about this for a little while, and now they use James Webb to study it very carefully. The planet has 12.7 times the mass of Jupiter, and it's about 1.2 times the radius of Jupiter. So it is definitely on its way to being a brown dwarf. But what's interesting about this planet is that it has a temperature inversion in its atmosphere. So here on Earth, at the low altitudes, the atmosphere is warm, and then it gets colder and colder as you rise in altitude. But on this planet, the temperature of the atmosphere starts out cold and gets warmer as you go up in altitude. And what's causing this heating? Well, it seems to have something to do with auroras in the rogue planet. And then how is a rogue planet having auroras? That's weird. We've seen other examples of brown dwarfs with potential auroras, and there seems to be some kind of interaction with the planet and maybe some kind of moon. This is something that can help cause a magnetosphere to interact with particles around it and generate these auroras. So it's a giant mystery around a rogue planet, which is one of this sort of really exciting class of planets. Check out the story from Lawrence Tognetti about this planet. And if you're interested in this topic, I did an interview with astronomer Joe Pesca about how we can detect exoplanets purely through detecting their magnetospheres. That's a totally different way to find other planets out there. And rogue planets, apparently. I cover a lot of stories about lava tubes on the moon and Mars, and for good reason. These are places that are protected from the radiation from space. The temperature inside these lava tubes can remain consistent. And when you think about Mars, these could be places where maybe there is ancient life in these lava tubes, or maybe some kind of geological record that we could explore. There's a lot of reasons to go and focus specifically on lava tubes. We know they're on the moon, we know they're on Mars, and now scientists think they've found examples of lava tubes on Venus. They were looking through archival radar data of Venus captured by NASA's Magellan spacecraft, which doesn't have a very high resolution, but they were looking in the regions around the giant shield volcanoes that are on Venus. Volcanoes which are larger than about 100 kilometers in diameter. They were looking for the telltale sign of a collapsed lava tube. So when the volcanism is happening around these shield volcanoes, you get the lava pouring down through these lava tubes. And then the lava goes out the exit of the tube, and you're left with this hollow tube on the side of the shield volcano. And then over time, these tubes can collapse, and you get these pits that form in a chain where the lava tube is. And so they found several examples, what seem to be these collapsed ceilings, and they move downhill, which is what you would expect if you were looking at something that was flowing down the side of the volcano. Now, I'm sure a lot of you are wondering, like, could you go inside these lava tubes? Like, is this a way we could protect astronauts who are going to be exploring Venus? But no, unfortunately, they're going to be just as hot as the surface of Venus. So they won't protect you. I guess they'll protect you from the sulfuric acid rain, but they won't protect you from the incredible pressure and the terrible temperature. We've got a story about this from Mark Thompson, and I look forward to your pronunciation advice in the comments below on how to pronounce lava. Here's the eternal question. Is our solar system normal? Now, we have all of these terrestrial planets close to the sun. We have the gas giants farther out, and then we have the ice giants beyond that, the Kuiper Belt, Oort cloud, and so on. But astronomers have been finding giant planets really far away from their stars. I'll give you one example, and this is like one of my favorite planetary systems, which is HR 8799. And this is the one where we can actually watch this frame by frame animation of the planets moving around the star. The closest planet is 20 astronomical units from the star, and the farthest one is 70 astronomical units away from the star. So that is way farther than anything we have here in the solar system. And yet we have found many examples of giant planets that have formed that far away from their stars. And that doesn't seem like it should be what you would expect. You would expect the gas and dust to be mostly available close into the star and less. So how do you get these giant planets so far out? Well, astronomers wondered if it has something to do with the spiral arms that form around these protoplanetary disks. So look at these incredible images of these like spiral arms. They look like little galaxies around stars. And these are where newly forming planets are starting to come together. And astronomers wanted to know, are those spiral arms turning and have planets inside of them where the spiral arms have the densest regions, or are they more like the spiral arms in a galaxy where there are these density waves that are moving through this protoplanetary material? Astronomers were able to resolve features in a protoplanetary disk around a star called IM Lupi, and they were able to tie the planetary formation to the densest regions of the spiral arms. And so it looks like the spiral arms are actually helping to concentrate material to where these new planets are forming, which can help allow them to form farther away from their star. It's an interesting idea. We've got a story from Andy Thomaswick, so you can check out more. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner this week was, should we blow up asteroid YR4? Is that a vote to blow it up? I don't know. But thank you everybody who voted. We're going to put the vote for this week's stories into the post tab on our channel. And then you go there, vote early, vote often. The best chance to see that is subscribe to the channel, click on the notifications bell, and then go into the post tab, find a bunch of our votes, vote on them, and then the YouTube algorithm will just start spitting them at you hourly. In 2024, astronomers directed James Webb to examine the atmosphere of Saturn. And they spent 10 hours just watching and watching and watching as Saturn slowly turned, and they were able to observe features in the atmosphere of Saturn. And of course, James Webb is viewing in the infrared spectrum, which allows it to see through the kinds of hazes, gas, and so on that's in the upper layers of the atmosphere of Saturn. And they were able to resolve some really interesting, very mysterious features on the surface, or I guess in the cloud tops of Saturn. They saw these dark bead-like structures and then an asymmetric star-shaped feature around the planet's polar regions. And what this seems to indicate is that there are these structures in the atmosphere of Saturn that are vertically very tall, and that they're actually sort of dredging up material from deeper layers and interacting. And so instead of, say, you've got these very thin cloud layers one after the other that are keeping to themselves, that you might have these structures that are vertically much larger and are interacting all the way from pretty much where it meets space to deeper down into the atmosphere. And that if we're seeing this kind of thing happen on Saturn, then this could be an indication that we'll see this on other giant planets as well, both here in the solar system as well as exoplanets around the universe. I've got a story about this from Matt Williams. All right, now it's time for some images. First up, here is a selfie from China's Tianwen-2 probe, which is on its way to asteroid 2016 HO3. And China does a great job of this, where they figure out a way to have every single one of its spacecraft able to take a selfie. Either there's some camera on a boom that's able to take a picture of the spacecraft, or they'll actually deploy tiny floating cameras that will take a picture of the spacecraft while it's in space. And it's cool, and I really love that they do this. But in this case, you've actually got an image of the spacecraft, and then you can see the Earth over its shoulder as it was doing a flyby of the planet. Tianwen-2 is currently 43 million kilometers from Earth, and it's about the same distance to its target asteroid 2016 HO3. It's going to retrieve a sample from this asteroid, bring it back home to Earth, and then go and visit a comet and continue to observe it. So we've got a pretty interesting future for this mission. And then the next image I want to show you is the largest star-forming region in the entire Milky Way. This is Sagittarius B2, and it is a gigantic cloud of gas and dust. It measures about 150 light years across and contains 3 million solar masses. And it's only about 400 light years away from the very center of the Milky Way. And this has been a long-standing puzzle, that you've got this region with stars packed incredibly close together, intense radiation, gravitational interactions from the supermassive black hole, and yet new stars are being formed in a region which seems incredibly difficult for new stars to survive. And this nebula is part of the central molecular zone that contains about 60% of the cold molecular gas in the entire Milky Way, but only 10% of its new stars. And we've got a great story about this and more images from Evan Goff. Now, are you enjoying all of this space news, but you wish there was like one more story? Well, good news. We do have a version of Space Bites with one more story. And that bonus story is about how astronomers looked through ancient Pioneer spacecraft data to learn that the clouds on Venus are largely made of water. Now, we released the longer version of this episode, which we call Space Bites Plus, over on Patreon. Now, it's completely free. There's no ads. You can just go over to Patreon and watch it right now. And I'll put a link in the show notes so you can do that. And then remember to do that in the future if you want that extra story. And if you still want more news, we are covering many more stories on Universe Today. We only have time to cover a fraction of them here in Space Bites. For example, what type of lander could set down on Jupiter's volcanic moon Io? Astronomers detect the first heartbeat of a newborn star, and an Einstein cross reveals the universe's hidden matter. Now, in addition to these stories being over on Universe Today, I'm writing my weekly email newsletter, which covers every single story that we are looking at this week. I read every word, there's no ads, it's completely free, and you can subscribe. Go to universetoday.com/newsletter to sign up. I'm going to talk about Comet 3I Atlas, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bailock, Cy Nelson, David Varibath, David Gilton, David Matz, Evan Pro, Greg Feely, Hudson Ward, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Spitz, Michael Purcell, Monzo, OneStepForAnimals.org, Paul Robach, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fowler Munley, Team 49, Vlad Shepelin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So nonsense on YouTube is reaching a fever pitch, and you could not see a better example of this than Comet 3I Atlas, which is absolutely a very interesting story. We have got an interstellar object that is passing through the solar system. This is the third one that we've ever seen. It is the fastest moving one ever seen. It is bigger than any interstellar object than we have ever seen. And on the day you're watching this, it will have made its closest flyby of Mars, and hopefully we're going to see a lot of really amazing new pictures of the comet. Its closest point at the end of October, perihelion, it's going to be on the opposite side of the sun, so we won't be able to observe it from Earth, but we will be able to observe it from a lot of other spacecraft. And so this is all genuinely exciting and interesting. The comet is weird. We're seeing amounts of carbon dioxide ratios that are different than what we would expect to see from comets that come from the solar system. This is clearly from another star system, and if we could get better observations of this comet, we could learn a tremendous amount about a completely different star system. But there is so much nonsense going on YouTube right now, and I've got to talk about this. Go ahead, start up an incognito browser, do a search for Comet on YouTube, and you will see what I'm talking about. No, do a search for space. Do a search for anything. You will see the amount of essentially cash grab AI slop videos that are showing up, mixed in with legitimate videos. And the amount of traffic that these videos are getting dwarfs anything that I'm getting, Astro Kobe is getting, other legitimate, hopefully, space journalists are getting as we're trying to talk about this incredible comet and this incredible event. And people are wondering, is it a spacecraft? Is it going to accelerate towards the Earth? Is it going to, like, it's driving me crazy. And like, I know I shouldn't. I should just chill and wait, because you know what's going to happen? Nothing. It's going to pass behind the sun. It's going to keep going. It's going to make its closest flyby of Jupiter. That'll be cool. And then it will keep going out into the universe. Nothing will happen from this comet. And yet people right now are hyping up and freaking out people and telling them that things are going to happen, and none of this is going to happen. So please, if you're started to fall into this conspiracy theory rabbit hole about Comet 3i Atlas, chill out. Don't worry. Everything's going to be fine. If you're like behind these machines, these AI slot machines that are generating enormous amounts of information about Comet 3i Atlas, please stop. Please. Freaking people out to make money. And it just means that people are going to trust astronomers less each time around. All right, well, rant over. Hopefully, I'll be able to share some pictures of Comet 3i Atlas next week. So we'll see you then.